Welcome to The Explainer. Have you ever really thought about how something goes from just an idea to the phone in your hand or the car you drive? Well, today we're going to pull back the curtain and decode the blueprint for creation. We're talking about the core principles of product design that turn everyday problems into the products that really shape our entire world. All right, so take a look at this. We've got a camera, a private jet, a staircase, and an engine part. I mean, what could they possibly have in common, right? At first glance, they seem completely random. One fits in your pocket, one flies at 30,000 feet, one's part of a building, and the other's buried deep inside a machine. But believe it or not, they're all connected by one single, powerful, fundamental idea. So on the one hand, you've got this tiny camera, right? It's designed to capture a single, fleeting moment. And then you've got a private jet, a machine built to soar across entire continents. We're talking about two incredibly complex products, built for wildly different reasons. And it doesn't stop there. Think about an elegant glass staircase. It's both function and art. Then you have these high-performance connecting rods. I mean, these are literally the tough, beating heart of an engine. And yet, all of these things, from the staircase to the jet, are born from the exact same core human activity. And that activity, it's design. Now, when I say design, I'm not just talking about making things look pretty. It's so much more than that. It's the conscious, structured process of seeing a gap in our experience, some kind of need, and creating a tangible solution to fill it. It's not just an activity, it's arguably the fundamental driver of all human progress. Okay, so how does this actually work in the real world? How do you get from some vague problem, this gap we just talked about, to an actual physical thing you can hold? Well, let's pop the hood and take a look at the engine of creation itself. You know, it all starts with a person, a user, someone just going about their day. And at some point, they have an experience where they feel this gap, a space between their current reality and a reality they'd much rather have. That gap, that's the spark. It's the little light that goes off signaling that there's a problem just waiting to be solved. Now, this is where it gets really interesting because what this does is it kind of formalizes creativity. The design process takes that gap and channels it through this simple four-step loop. First, you sense the gap. Then, you define the problem. You really nail down what it is. Next, you explore alternatives. And finally, you select a plan. And the key here is that this isn't just a one-way street. It's a loop, a cycle that you can go through again and again, refining the idea each time. And look, this isn't some brand new modern business school theory. Not at all. It's a pattern of human ingenuity that's been around for centuries. And there is no better example of this in action than one of America's most famous founding fathers. Yeah, let's talk about good old Ben Franklin. He sensed a gap, a personal one. Picture this. He's at a dinner party, and he's getting super frustrated because with one pair of glasses, he can't see the food on his plate clearly. With another pair, he can't see the faces of the guests across the table, so he's just constantly switching back and forth. That was his gap. So what did he do? He defined the problem. He needed different corrections for near and far vision, but in one place. He must have explored a few alternatives, and then, as you can see right here in this actual letter from 1785, he selected his plan. He even sketched out the design for his bifocals. And his own words here just perfectly nail the solution. I had the glasses cut, and half of each kind associated in the same circle. By this means, I have only to move my eyes up or down. It's so brilliantly simple, right? He went directly from his personal gap to an artifact that would literally change how the world sees. That's the design process in a nutshell. Now, Franklin's solution seems so obvious in hindsight, doesn't it? But that explore alternatives step, man, that can be completely paralyzing. You could have infinite options. So how do designers actually navigate that world of possibilities without getting totally lost? Well, they build themselves a map. They do it by corralling the complexity. Instead of trying to solve for every single variable all at once, they create something called a design space. The best way to think of it is as a simplified world, a model of the problem, where you're only focusing on the absolute most critical decisions. Let's make this super simple with an example. Imagine you're designing a garden shed. Instead of being overwhelmed by infinite choices, we create a shed world with just a handful of key decisions. Step 1, choose a wall height. 2, choose a floor plan shape. 3, choose a roof type. And 4, choose the pitch of that roof. All of a sudden, just those 4 simple choices can generate
hundreds of completely different sheds. It makes exploring the options totally manageable and systematic.
All right, now we're going to get into what is honestly one of the most critical, yet often completely invisible decisions a designer makes. This is a choice that happens super early in the process, and it dictates almost everything that follows. We're talking about the product's architecture. See, every single thing ever designed has an architecture, and it usually falls somewhere on a spectrum between two big ideas. On one end, you have a modular architecture. Think of these components like Lego bricks. They're independent, they're interchangeable. On the other end of the spectrum, you have an integral architecture. This is where the components are all tightly woven together, highly integrated, and often share functions. The huge advantage of a modular design is flexibility. The classic example is a desktop PC, right? You can easily pop it open and swap out the graphics card for a better one, add more RAM, or upgrade your storage. This modularity is what allows for endless customization, super easy repairs, and it even creates a whole ecosystem for other companies to make add-ons. Integral designs, though, they make a completely different trade-off. What you sacrifice in flexibility, you gain in peak performance. By weaving all the components together so tightly and making them share jobs, designers can create systems that are way lighter, smaller, and more efficient than any modular system could ever hope to be. And here is a just brilliant, real-world example of that. This BMW motorcycle. Now, on most bikes, you have a frame, and the engine just sits inside it. But here, the designers asked a revolutionary question. What if the engine is the frame? And that's exactly what they did. The actual engine casing becomes the main structural backbone of the entire motorcycle. This incredible strategy is called function sharing. You take a single component and you design it to do multiple jobs. This gets rid of redundant parts, which saves a ton of weight and space. This concept, it's really the soul of an integral architecture. It's how you push the absolute boundaries of performance. So what are the big takeaways here? First, design isn't magic. It's a universal process for solving problems. Second, it follows that simple but really powerful loop. You sense a gap, you define it, you explore your options, and you select a plan. And finally, one of the most critical choices you'll make is the product's architecture, whether to go modular or integral. That decision has massive consequences that define not just the product itself, but the entire experience of using it. So, now that you've seen the blueprint, I want to leave you with a final thought. As you go about your day-to-day, start looking at the world differently. Look at the objects around you, your phone, your chair, your coffee maker. Can you spot the invisible architecture? Can you tell if it's modular or integral? And more importantly, what does that choice tell you about the real problem it was originally designed to solve?